Hi everyone, today is our weekly GOlang educational video, and today we're gonna talk about caching. We will build a small application which has one API endpoint, which has a connection to the database and a lot of data in the database. So we will see that when it comes to heavy queries to the database, it may take some time to process your request. So if you have API endpoint which is pretty heavy with traffic and you have complicated resource-consuming queries to the database or to any third-party service, you may want to use cache. So what is cache? Cache is some middleman between application that you're building and between the data source. Is it a database or any third-party application? So in this middle layer, you can store data and you can access this data much faster than you would access it directly to the database. Mostly because the data is already processed in this cache and it's already ready to be just sent back to the client. So caching is widely used today in many decently loaded applications. We will have today one table in our database which is called products. This table has just two columns, ID and name. And I generated about 1 million records into this table just for the demo purpose. So we can check, for example, that all in all we have, yes, 1,000,001 records in this table. We use just a regular MySQL database. Okay, so we have our database, we have our table with about 1 million products here. So let's check how much time does it take to make a full text search on this database by the column name for the database itself. So we can see that running that simple query for searching the products that matching our search query using the like operator, using the percentage symbol in the beginning and in the end of the query, meaning end of the string, meaning that we want to find all the products which have this string, this text inside their name. So we found about 20 products here, and it took database to, on my local laptop, it took database to 400 milliseconds to find these products, which is already quite a long time for query to run, because if you have a heavy loaded application and each request takes 400 milliseconds, very fast you may exert your database capacity and server capacity. So basically you can end up with the non-responsive service pretty much fast if you have a decent loaded API endpoints. So let's see how can we leverage cache to solve this problem and to make our API work faster. Okay, so let's take a look at our application. So we have our very simple application which is based on Go modules, which I talked about before in my very first video. You can check it in the link below. So what we have here, we have our main package, we have our struct product, which represents the same data structure as we have in our database in the table products, which has an ID, it has name. I will be just copy pasting the code from earlier prepared main Go file just to make it faster. Next, we use GORM to establish a connection to the database. GORM is very handy ORM tool that gives you pretty easy way to access and to work with the database. So first you open the connection. So yeah, very first you make the global variable, in our case, which is goramdb, which will be used throughout the application. Here in the main function, we open the connection to the database. We telling GORM that we're using MySQL driver, which we also need to define on the top. So we're using MySQL driver, we have these credentials to our database, and we have product, we have main function. We're using GORM to open the connection to our database. Then we check if connection is successful, and on defer, when we exit main function, when the application stops, we don't forget to close the connection to the database. So next we have here our handler of our single API endpoint, which is the root path. Then we open basically and start HTTP server using the standard library HTTP, listen and serve on port 8080. Again, everything, all these parts I explain in details on my first video, which you can take a look later. But here is our API endpoint. So what do we have here is we take the parameter from our API call, get parameter, which called name. Basically, this is our search parameter. We also define that if it's less than 3 symbols, then we don't want to actually perform a search. We want to have 3 and more symbols to be entered before we start querying the database. Usually it's a good way to limit the search to 3 and above symbols, just because if you type A, you probably will end up with having all the products that you have in your database, just because this is such a wide selection of data that you have. So it's a good practice to have this limitation, but again, it all depends on your specific application. In our case, just for the sake of example, I have here the validation for the name parameter be more than 3 symbols. Otherwise, we will just respond with the status bad request. It would be nice also to tell why is bad request happened here. So for example, we will write here the message too short name search parameter. So in this case, the client will get the response code bad request as well as the details of the error itself. Okay, next we define the list of the products which will be the result of our search function. Then we build our query using the GORM, using the database that we established a connection to before. So this is our global object. We use this database. We tell the GORM that we're gonna use the struct, the model product. This is the model that we defined here as a struct. Then we tell that, okay, we want to find all the products which has name like a parameter, and the parameter here will be this one. Here we use as printf to actually compose the string, which will look like this: my search. So based on the MySQL specifications, you know that if you use the parameter like and you wrap your value into this percentage symbol, it means that you're looking for this string to be matched anywhere in this column name. So you want to so it's a full text search basically. Yes. Okay, so next we want to store the result of our search in the variable that we defined earlier, list, and then right away we want to check if there are any errors. So if there are any errors, and the error specifically is not that nothing has been found, then we just report this error. We tell the client that we have some internal error, and we log this error in our standard log. Then if we got error record not found, then what will happen is we want to respond to the client that with the standard HTTP code status not found, which is 404. Again, it's not always a good way to use the standard HTTP response code, because usually 404 it's when the API endpoint itself is not found. So it's not that when the result is not found of the, for example, in our case of the search, it's when the API endpoint itself not found. So if you use this inside your API, it could be a little bit ambiguous because the client might not understand, is it the broken link, or it's the content which is not found. So usually what you want to have here, instead of the status not found, is just to respond with the empty array. So it will be just an empty JSON array. But in our case, for the sake of the example, we will respond with a 404 standard HTTP response code. What we have next is basically we take our list and we convert it into the JSON. We use Marshall indent in our case, which will not only convert the array of objects into JSON format, it will also make it look nice. So we will be able to see it formatted pretty, not just like a string. It will be with all indents, new lines and everything. We'll take a look at that later. So now, as we have our JSON as bytes from the standard library Marshall JSON Marshall function, then we basically write it out to the client. And for this example, let's test it, and we will use Insomnia as our tool to create the HTTP request. So it's our local host, our port 8080, we have the parameter name. For example, we want to send the request with the name parameter 5555, so we want to find all the products which has 5555 in the name. In this case, we got this number of products. It took us about 403 milliseconds to run this API call, which is quite a lot. So now, as we have our application works directly to the database, fine, let's try to put some load on our application and see how would it be, perform if we have a lot of requests like that with the current structure of application and with the current direct to the database requests. Okay, let's use a tool called Hey. This is a very handy tool for small load tests, which allows you to specify how many of requests do you want to send to the application, to your endpoint, how many concurrent workers do you want to run, etc. So in our case, we will be using Hey to hit our local host API endpoint with the search parameter name equals to 5555. We will start with a 50 request to this endpoint. Okay, so what we got here is, I'll make it a little smaller. So what we got here is the fastest one was 8 seconds, the slowest one was 8 seconds. It was 5 requests a second performance-wise, and we got here this latency distribution. So 95% of requests were finished within almost 9 seconds, 10% within 8.5 seconds. So basically, we can say that our API endpoint is pretty damn slow when it comes to load like 50 requests with the 20 workers running at the same time. So I would say this API, if you would push it to production to any decently loaded service, will not survive too long. So let's check how can we improve our app with the Memcached. So what we're gonna do here is first we will declare another global variable, which is a Memcached, just right after our database connection. Memcached client. This is a global Memcached storage that we will be using in the app. The next one, let's establish a connection to the Memcached server itself. So now I have a connection. Now I have a Memcached locally on my laptop. So we'll be using just default 11211 port. So as I know that installed in my and running on my laptop, and this should work just fine. Next one is basically in our handler. First, before we will be reaching the database here, we need to check if we have the data already in the cache. So in order to try to get the data from cache, we will define the key. So the key of our Memcached record will be products underscore and the search parameter name, because we need to store the cache records based on the parameter name that's coming from the client. Otherwise, one search will override another search and it will have not a valid response data. So we build our key based on the products underscore search name. Then we trying to get this data using the Memcached connection, and here, if everything goes fine, we found our data, we will set header key cached into value 1. So on the client side, we can check that the value we got is actually from the Memcached and not from the database. And then we will just write into the client the data that we got from the cache. And that's basically it. And if some error happened, for example, and it's not the error that indicates that the cache is missing, then we want to log this error, because we don't know what exactly happens here, but we want to know that something is wrong. For example, Memcached is not running, timeout or anything like that. And then, regardless if we have missing cache error or any other error, we'll just go by our existing flow directly to the database. We will fetch our products here, marshal them into the JSON, and return back to the client. This will run only in case if the cache was not found in Memcached. But how we actually store the data in the Memcached? Yeah, so here when we got the data from the database, we need actually to store it into the Memcached. At this point here, after we converted our list of products into the JSON, here we actually will set our Memcached value, and for that we will use the function set. We will use the Memcached object item. We define a key here, which is a products underscore name. The value will be the marshaled JSON object with our list of products, and the expiration time that's set in seconds. We will cache our data for 10 seconds, meaning that the data that we having here will be sitting in cache for 10 seconds, and after that the data will be gone from cache, and at this point we will see that there is no data in the cache, so we will reach the database again. So our data might be outdated as long as 10 seconds because we have a cache in place, and if the data is updated in the database, we will not return it to the client for maximum 10 seconds while we're getting the data from the cache. Okay, so what do we have here is, let's define our error a little bit up. Okay, so let's try to run this application and see how that will work. We're running our application. We go to our API call tool. We send our first request and it takes 516 milliseconds to run. We send the same request second time and we can see that our request took 0.7 milliseconds to run. If we hit it again, it depends if 10 seconds passed, then we have again 560 milliseconds, meaning that the data in Memcached expired, it was gone, and the application was hitting the database again. So we send it again, request more than 10 seconds passed, and we again see that the response time is quite long. But if we hit it within 10 seconds, we see that each and every other response is very fast. It's like less than a milliseconds. And we also can check that in the headers that the application sending back to us, there is a flag cached one, meaning that here when we set this flag into 1, we notify the client that the data is cached. This is a very simple example how we utilized cache in order to speed up the exact same HTTP API calls and to be able to actually run much faster. So let's now try to use a tool in order to run the same performance and small load test that we did before. So now we will run again exactly the same test as we ran before, hitting our API endpoint 50 times with the 20 workers running simultaneously, and we will see the stats and how is it different from what we had before. So now you can see here that the performance of our application is much better. This is how we optimized our API endpoint using Memcached to cache the data that we get from the database and speed up our application. The only thing you need to remember in such case is that it only works for the same exact API calls. For example, if someone is searching the product name 5555, like we have in our example, many times, like we have first request is long and other requests are very fast, but then you change the search criteria, for example, to 5552, you see that it takes again a long time to process. And why is it happening? Because we caching the products based on the name that the user is searching, and that means that if you change the name, the data is not there, so it will go again to the database and will perform this resourceful operation of looking for all the products in your database. So in cases like this, if you need to perform a full text search, usually using cache is not exactly a good way to solve this problem, because most of the users will search the product using different keywords and different products. So caching is not so much helpful here, because you will have a lot of different names in this case, and most of the requests will eventually hit the database instead of getting the data from the cache. Just because of the variety of different search criteria. So in this case, usually if you need to do a full text search, you would want to use something like Elasticsearch. It's an alternative database which is extremely good with a full text search. It's not a relational database, so it has a completely different structure there. And in my projects, in one of the projects that I have basically MySQL as a master data, and I have Elasticsearch as another database which has the data from the master database for those tables where I need to perform the full text search. In this case, whenever I have a full text request on my API endpoint, I actually talk to the Elasticsearch database because it's so much more efficient with a full text search. And whenever I need to do some calculations or relational operations, I will talk to my master MySQL database. So in this case, we use a full text search just for example, just to have some very slow SQL queries. But usually cache is not so good for full text search. Usually you want to use cache when you have a lot of left joins, complicated queries, taking the data from the multiple tables, like big tables, for example. Then you want to utilize cache in order to decrease the load on your database and cache the data for the similar HTTP request. This is a simple application that uses Memcached, that uses database, and here I showed you basically how does it improve the performance of your API service. And again, this all structured here in one file, which is not so easy to read now. Usually you want to split it. You want to have your caching, could be even a middleware which you attach to your API handlers. So for example, some API endpoints, for example, you know that you want to cache them. So you add this middleware with the cache, and based on the HTTP URL and all the parameters there, you may combine a key, for example MD5 called MD5 hash of the URL with all the parameters, and the resulting payload you can cache there on the middleware, and next time when somebody hits your API endpoint with exactly the same URL and all the parameters, you just retrieve the data from the Memcached. It's pretty much the same logic as we had here. It's just you take this Memcached connection and Memcached logic into the middleware. For example, if you want to use caching a lot in your application. This is pretty much all that I wanted to cover today in this video. So if you enjoyed this video, if you find it helpful, please click the like button. It will really help YouTube algorithm to recognize my video and to pull it on top for other beginners in Go. That's it for today. Thank you so much, and bye bye.